Understanding sectors of a circle. Welcome, everyone. Today, we are beginning a new subsection where we will explore the concept of a sector of a circle. It is important to grasp this idea early on, as understanding sectors is fundamental to mastering more complex geometric calculations, specifically when we need to find areas and arc lengths. You will find that these calculations are not just theoretical. They are frequently applied in real-world professional fields such as engineering, architecture, and design. So, let's dive in and see what exactly defines a sector. What is a sector? Now that we've introduced our topic, let's dive into what a sector actually is. To visualize this, I want you to imagine a flat, circular disc in front of you. Now, pick a point exactly in the middle. This is your center. From that center point, draw two straight lines, which we call radii, extending out to the edge or the circumference of the circle. As you look at these two lines, notice the curved edge of the circle that connects their two endpoints. This curved part is what we call an arc. The specific wedge-shaped area that is trapped or enclosed between these two radii and that arc is what we formally define as a sector. Think of it as a specific piece of the whole circle. Components of a sector. Now that we have a general idea of what a sector looks like from our previous slide, let's break it down into its specific parts so you can identify them accurately in any problem. First, we have the center, which we denote with the capital letter O. This is simply the fixed point located exactly in the middle of the circle. Next, we have the radii. These are the two straight line segments that start at our center, O, and extend out to the edge, or the circumference of the circle. Then we have the arc. If you look at the boundary of the circle, the arc is that specific curved part that connects the two endpoints of our radii. Finally, we have the central angle, which we represent using the Greek letter theta. This is the angle formed where the two radii meet at the center. It is very important to remember that the size of this angle, theta, is what actually determines how large or small our sector will be. This leads us directly into our next topic, where we will see how different angles create different types of sectors. Types of sectors. Now that we have identified the individual components of a sector, the center, the radii, the arc, and the central angle, we can look at how these parts actually divide the circle. You see, depending on how large or small that central angle, which we denote as theta, the circle is split into two distinct and different regions. Minor sector. Now that we have established that a circle can be divided into two distinct regions based on the size of the central angle, let's focus on the first type, the minor sector. You can think of this as the smaller slice of the circle. If you were looking at a pie or a pizza, the minor sector would be that single, smaller piece you pull away from the rest. It is also important to note a convention you will frequently encounter in your exams. In most mathematical problems, if a question simply uses the word sector, without specifically labeling it as minor or major, you should generally assume that the question is referring to the minor sector. Major sector. Now, moving on from the smaller slice we just discussed, let's look at the other side of the circle. The major sector is simply the larger portion of the circular region. If the minor sector is the small slice you've taken, the major sector is everything else that remains. Calculating the angle of the major sector. Now that we have identified the two different types of sectors, the minor and the major, let's look at how we actually calculate the angle for that larger, major sector. Think back to what we discussed regarding a full rotation. We know that a complete trip all the way around the center of a circle is exactly 360 degrees. Because the minor sector and the major sector together make up that entire circle, finding the missing piece is quite straightforward. To find the angle of the major sector, you simply take that full 360 degrees and subtract the central angle of the minor sector, which we have been calling theta. In mathematical terms, you can express this as the angle of the major sector equals 360 degrees minus theta. To make this concept even more concrete, let's move on to a real-world example using something everyone loves: a pizza. Real-world example: the pizza analogy. Now, to help you truly visualize these abstract geometric concepts, let's step away from the diagrams for a moment and consider a very familiar real-world example: a standard circular pizza. Step 1. Creating a minor sector. Now, let's apply what we've just learned to a real-world scenario using the pizza analogy I mentioned on the previous slide. Imagine you have a fresh, circular pizza in front of you. When you take a knife and make 2 straight cuts from the center of the pizza out to the edge to pull out a single slice, that individual slice represents what we call a minor sector. If you look closely at the geometry of that slice, the 2 straight edges created by your cuts are the radii, and that delicious outer crust represents the arc. Now, let's look at the measurement. If the angle formed at the center of the pizza for this specific slice is 45 degrees, then we would denote our central angle, theta, as being equal to 45 degrees. This sets the stage for identifying the larger portion of the pizza in our next step. Step 2. Identifying the major sector. Now, let's look at what happens to the rest of the pizza. Once you have removed that single slice, which we just identified as our minor sector, the large portion of the pizza left behind in the box represents the major sector. Just as the slice was the smaller part, this remaining piece is the larger, more expansive region of the circle. Step 3. Calculating the major angle. Now, let's put everything we've discussed into practice to find the angle of that remaining portion of the pizza. To find the angle of the remaining pizza, which we've identified as the major sector, you simply need to subtract the angle of the slice you took from the total degrees in a full circle. Mathematically, we express this as the major angle equals 360 degrees minus 45 degrees, which gives us a result of 315 degrees. This calculation confirms exactly how much of the circular area is left in the box. Common mistakes to avoid. First, please be careful not to confuse a sector with a segment. I know they sound similar, but they are structurally different. As we discussed earlier with our pizza analogy, a sector is bounded by 2 radii and an arc. Think of that perfect pizza slice. A segment, however, is bounded by a chord and an arc. It looks more like the small cap or the edge of the circle that you'd cut off if you slice straight across without going through the center. Second, watch out for errors when calculating the major sector. A very frequent mistake I see is students forgetting to subtract the minor angle from 360 degrees. When you are working with the larger portion of the circle, you cannot simply use the original theta angle. You must use the complement, which is 360 degrees minus theta. Finally, never ignore your units. It sounds simple, but always ensure that your central angle, theta, is clearly defined in degrees before you begin plugging numbers into any formulas. Now, before we wrap up our lesson, I want to pause and highlight some common pitfalls. As you move on to more complex geometry problems, you'll want to be extra careful to avoid these 3 mistakes. If you keep these 3 points in mind, you'll be well prepared for our final summary. Key takeaways. First, remember that a sector is simply the region of a circle enclosed by 2 radii and an arc, just like that slice of pizza we discussed earlier. Second, we use the Greek letter theta to denote the central angle formed at the center of the circle. Third, we distinguish between 2 types of sectors based on that angle. The minor sector is the smaller region, which occurs when theta is less than 180 degrees. Fourth, the major sector is the larger portion of the circle, and its central angle is calculated by taking 360 degrees minus theta. Finally, always keep in mind that the sum of the angles for both the minor and major sectors must always equal 360 degrees, representing 1 full rotation. All right, we have reached the end of our lesson, so let's quickly recap the key takeaways to ensure everything is clear before we move on to our practice problems. If you have mastered these definitions, You are now ready to tackle more complex calculations involving arc length and area.